Triangles chapter exercise 2.2 first problem first question. In figure DE parallel to BC find EC. We want to find EC in this figure. In triangle ABC DE parallel BC. So by Thales theorem we can write AD by DB is equal to AE by EC. So we will substitute the values of AD. AD is 1.5 centimeter and DB is 3 centimeter. AE is 1 centimeter and EC is what we want to find here. EC, how much? So here 1.5 ones are 1.5 twos are. So 1 centimeter by 2 centimeter is equal to, if not here centimeter cancels, so 1 centimeter by EC. So by cross multiplication we can get EC is equal to 2 ones are 2 centimeter. EC is equal to 2 centimeter. This completes this problem. In triangle, let me read the question right now. In figure DE parallel BC, find AD. What we have to find here is AD we have to find. This is a simple calculation. In triangle ABC DE parallel BC. So by Pythagoras by Thales theorem, that is AD by DB is equal to AE by EC. Basic proportionality theorem. Here also we can write basic proportionality theorem. If not Thales theorem we can write. So let us substitute the values. AD by DB is 7.2 centimeter. Here AE is 1.8 centimeter by 5.4 centimeter. So AD is equal to 7.2 centimeter on cross multiplication into 1.8 centimeter by 5.4 centimeter. Here centimeter cancels. 0.8 ones are 0.8 threes are. So AD is equal to 7.2 centimeter by 3. So let me divide 7.2 by 3. 3 twos are 6, 1. So it's not possible. Let me put a point here. 2. 3 fours are 12. So AB is equal to 2.4 centimeter. This completes this problem. Second problem. E and F are points on the side PQ and PR respectively of a triangle PQR. For each of the following cases, state whether EF parallel to QR. The readings are as follows. Let us not deal right now. We will be constructing a triangle PQR. To understand the problem properly. So here, let me take P, this one Q, and this one is R. E and F are the points on the side PQ, E. Let this be E and R, F, PR. PQ is the point on PQ and F is the point on PR respectively of the triangle PQR. For each of the following cases, state whether EF should be a line here. Let me draw a line EF. We should check whether these two lines are parallel or not. So in the first case, let me deal with the first case. In triangle, let me take as per the converse of the Thales theorem, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. If this side, this one and this one, this side, if PE by EQ and PF by FR are equal, if they are both are in same ratio, then the sides EF and QR will be there in the, both are parallel. If not, it is not. So let me take PE by EQ. What is PE here is 3.9 centimeter in the first problem. EQ is 3 centimeter. 3 centimeter. So what happens here? Let me divide it here. So what I will get means 1.3. I will get 1.3 by 1. So let me move on to PF by FR. PF by FR. What happens here? PF, what is that? PF is 3.6 centimeter by FR is 2.4 centimeter. Here centimeter cancels, here 2 centimeter cancels. So what we want to do here is 12. This one is 12, 1.22. This one is 1.23. So which is equal to 3 by 2 is equal to 3 by 2 is 1.5. So PE by EQ does not equals to PF by FR. Therefore, EF is not parallel to QR. That completes the first problem. By Converse of Thales theorem, we will be solving all the three problems with the help of Converse of Thales theorem. Now let me move on to the second problem. So PE by QE. PE by QE is there here. PE is 4 centimeter. QE is 4.5 centimeter. Here 2 both cancels. Here 8 by 9. This one is 0.5 into 8. 8 by 9. This one. Next we want to move to PF by FR. PF by FR. PF by FR is equal to, PF is 8 centimeter by FR is nothing but RF is equal to 9 centimeter. So centimeter cancel, so 8 by 9. So therefore here we can write PE by QE is equal to PF by FR. So the sides of a triangle PQR are divided by EF in the same ratio. Therefore, we can say that EF parallel QR by converse of Thales theorem. By converse of Thales theorem. Now let us move on to the third problem. Here too, PE by EQ. Here also we will use the same PE by EQ. But here PE is given. PE is equal to 0.18 centimeter. It is given. EQ is not given. EQ. But PQ is given. PQ is equal to 1.28 centimeter. So we want to calculate EQ. How to calculate means PQ is equal to, PQ is full line, so PE plus EQ. So PQ is equal to, PE is equal to 0.18 centimeter plus EQ. So what is PQ? Is equal to 1.28 centimeter. When we shift this one to the left hand side, it will be 0.18 centimeter plus EQ. Sorry, is equal to EQ. So when we subtract that one, 1.1 centimeter is equal to EQ. So EQ, now we will substitute this EQ here in 1.1 centimeter. So this cancels. So what happens when we multiply? Let us multiply with 100. So 0.18 into 100 by 1.1 into 100. So what we will get here is 18 by 110. So we will be getting 9 by 55. 9 by 55. Now let us move on to the next value, that is this side, PF by FR. We want to calculate this also. So if this is 1, let me calculate the other side. So what is PF? PF is given here 0.36 centimeter. FR is not given, but PR is given, PR. So let me calculate. PR is equal to, what is the value? Means PR is equal to 2.56 centimeter. So PR is equal to PF plus FR. So PR is 2.56 centimeter is equal to PF is 0.36 centimeter plus FR. So let me shift this one to the 0.36 to left hand side. So 0.36 centimeter is equal to FR. So what happens here? Let me subtract this value. 2.2 centimeter is equal to FR. So let me substitute this in this equation. So what happens? 2.2 centimeter. Here centimeter cancels. If we multiply this value to the with 100, we will be getting 36 by, let me multiply this with 0.36 into 2.2 into 100. Likewise here 2 with 100. So what happens here? Let me write PF by FR here. So 36 by 220. So this can be written as 9 into 4 by 55 into 4. So 4 cancels, which is equal to 9 by 55. From this, let this be 1, let this be 2. Therefore, from 1 and 2, we can write that. From 1 and 2, we can write that PE by EQ is equal to PF by FR. Therefore, we can write that EF parallel to QR. EF parallel to QR. Converse of Thales theorem. By converse of Thales theorem, this problem is completed. Third problem. In figure, if LM parallel to CB. LM parallel to CB. And LN parallel to CD. LN parallel to CD. Prove that AM by AB, AM by AB is equal to AN by AD. So first, let me try. In triangle ABC, LM parallel to CB. LM parallel to CB. So we can write AL by LC is equal to AM by MB by basic proportionality BPT, by basic proportionality theorem. Next, in triangle ADC, LN parallel to DC or CD. So here too we can write AN by ND is equal to AL by LC. So here this is also because of by BPT. Let us take this one as 1. Let me take this as 2. So what happens here from 1 and 2? From 1 and 2. Here AL by LC. Here 2 is there. AL by LC here also is there. So we can write AM by MB is equal to AN by ND. By axiom 1, what you have studied in the earlier classes, the things which are equal to the same thing are equal to one another. You can write axiom 1. The things which are equal to the same thing are equal to one another. Now what we have to take means, let me take the reciprocal of this one. Let me write the denominator in the numerator. MB by AM is equal to ND by AN. What do we call this means? Taking reciprocals. Taking reciprocal. Taking reciprocals. That means writing the denominator in the numerator and the numerator in the denominator is called as taking reciprocals. Add 1 to both sides. MB by AM plus 1 is equal to ND by AN plus 1. So what we have to do means MB plus AM by AM is equal to ND by AN plus plus AN here. How this works means, let me work for this one. You know, MB plus AM plus 1 is plus 1 by 1. So we should take the LCM for these two. So what happens means the LCM will be AM. So here you have to multiply with AM here also AM. So what happens? MB plus 1 into AM is AM. Likewise for this also we should take the LCM and we will be getting like this. So you understand here, MB plus AM, MB plus AM, MB plus AM is nothing but AB by AM, AB by AM is equal to ND. Where is ND? ND plus AN. ND plus AN is nothing but AD. AD by AN. So What we want is the reciprocal. So let me write the reciprocal of this one, this equation. AM by AB is equal to AN by AD by taking reciprocals. By taking reciprocals, what has to be proved has been proved.